A stack in computer science is a linear data structure that follows the principal lesson first out.
Don't forget to subscribe to my channel and hit that like button if this helped you out. Jokes aside, let's get back to basics and explore the practical uses of stacks. Here's the timecode of the video so you'll use it as you need. Imagine you're out in the snow with your friends, creating snow angels on the ground. Everyone's having a good time until your friends decide to play a little prank. They pile on top of you, forming layers of a human red velvet. It is hard for Blue to get off this cake because those who are on top of him are heavy. As each friend gets off, starting from the top, then the next, and finally, the Blue is now free. Congratulations, you've just experienced the principle of last in, first out. Now let's break it down. If you have a data structure that follows the last in, first out principle, you can call it a stack. So let me clarify with another example. Here is a well. We push items downwards the well. We push the first, second, third, and lastly the fourth. When we want to get the items back, those numbers are reversed because we get them upwards. And now as we firstly should get the item on the top and remove it from the well, we go down continuously until the item that we pushed the first. I can almost hear you asking, why do we need it? Where is it used? It is used for undo redo features in your software, Ctrl Z, moving back and forth through your browser's history, and everyday coding adventures like syntax parsing, making sure your code speaks the compiler's language, expression evaluation, changing your code tone from infix to postfix, and of course call stack functions, the behind-the-scene maestro of code's performance. We will talk about this in future videos. So let me show you how stacks are used in both C++ and JavaScript. Let's fill up our C++ file with my usual shortcut, cpp. And firstly, we need to create a new empty stack. How we do this? First of all, we need to include the library called stack. Then we write stack and we provide the type of the elements within this stack. Maybe integer, it may be char, or it may be string in our case. And we call this stack friends. The first built-in function of stack is push. So what does push do? It basically pushes the elements into the stack. Let's call this function friends.push, and we provide the value. In this case, it's string blue. Next built-in function is pop. Pop just removes the top element from the stack, so let's call it friends.pop. Then function top, it returns the top value from the stack. Let's create a string variable called output, which will be equal to friends.top. And let's print this output out. As you can see, we have nothing printed. It is because we have pushed and then we have popped and we have nothing within the stack now. So let's comment this line out, and as you can see, we have printed out blue. Also, we have function empty. It returns the boolean value which states whether our stack is empty or not. Now we create a boolean variable called isEmpty. It will be equal to friends.empty. And now we have to make a condition. If our stack is empty, then we print out empty. With an ending line, and else if it is not empty, then we print out it is not empty with an ending line also. We want to copy this printed top element of the stack. And we can comment this out. Let's run our code and check. Yes, it says blue and that the stack is not empty. What if we have nothing in our stack? Let's run our code again. Yes, it says that our stack is empty now. Now let's get rid of the comment. Then the last but not least function is size. Size returns the size of the stack. Let's create an integer variable called stack size, which is equal to friends.size. And let's print it out. Cout stack size with an ending line. It says blue is not empty and we have one element within our stack, which is correct. What if we have pushed the second element called red? It says red is not empty and we have two elements within our stack. Now we comment out all of the things we have written because we are going to the example that we had on the first animation. We create a new empty stack with string elements called friends. And we push the first element on the top of the stack, blue, and the second, red, and the third, green. And we want to output those. Firstly, we make a while loop, which has a condition it runs only if the friend stack is not empty. At first, we want to output print out the top element of the stack. Then we need to pop the top element also. Let's clear this console and run our code. As we can see, we have pushed firstly the blue, then red, then green, and then in the output we get the top elements as green, red, and then blue. So for JavaScript part, I switched to WebStorm because I find it much more convenient. And first of all, for the JavaScript, we need to understand that it has no built-in data structure called stack, so we need to implement it by ourselves. Let's create a class called stack and make a constructor within it to create a new object called stack. Within the constructor, we have this.items is equal to an empty array. Then we create a function push which accepts an element, and we write this.items, the stack that we already have created, dot push element. Then the next function is pop. We just write this.items.pop as we do with arrays. And the size function, we return this.items.length. It is as easy as this. And for top function, we create a constant variable called stack size, which is equal to this.size. We use the function that we have already created and we make a condition. if stack size is greater than 0, we return this dot items with the index of stack size minus 1, because if the length of the stack size is equal to 5, then the last element of the stack will have the index of 4. If stack size is less than 0, we return undefined. And of course, we can write this condition in just one line, with ternary operator stack size greater than 0, and we provide those values. We can comment this out. For the function empty, it will be pretty easy. We just make the condition if this dot size, we will check the size is greater than 0, then we return false. Because if it is greater than 0, we have actual quantity, then the stack is not empty. If it is not, we return true. Of course, we can simplify it and write in one line. So finally, we can do the same thing with it in C++. Creating a constant variable, a stack, we need to write new stack, with which we are calling the constructor function within the stack class, and it creates this dot items, which is an empty array. We have created an empty new stack. And next, we push to the friend stack the blue, and I'll duplicate it 2 times, and we change the blue to red and the last blue to green. Now we can do the same while loop, which will work only if the friend stack is not empty. Where we print out in the console.log friends.top, we are getting the top element, and we pop the top element of the stack friends. Let's check it. And as you can see, we have pushed blue, then red, then green, but in the output we had green, red, and then blue.
Let's dive into a few challenges. If you've got the knack for solving these problems, drop your hints in the comments below. To confirm your solutions, take a peek at the GitHub repository linked in the description.
There are
3
easy to hard questions.